Dart 3 has brought in a lot of new features. In this video, we are going to look into some of these features, namely records, patterns, pattern matching, and class modifiers. So let's get started with the first feature, records. So let's consider you want to return multiple values from a single function. Before Dart 3, one of the approaches you could take was to return a list from the function. And when you called the list, you got access to values and could retrieve the elements using the 0th and the first element. And then when you ran it, you got those values. Now just tweaking this example a little bit, what if instead of double, I want to return a string now? Now this can't be a list of double. This has to be a list of dynamic because I'm returning two different data types. And now if I run it, I get the correct values. But there are a few noticeable issues with this. First one is that we don't know the data type of this value at compile time. So this is dynamic as of now because that's what the list returned. And the second one is this function is less expressive. That means we don't know what's being returned from this function. We just know a list is returned, but what does the list carry? What each value represents here? And if we want to return more than 5 things, we wouldn't know what value is for what. So a better solution to this would be to use classes, right? So you could go ahead and create a new class with a double value in it and a string value, and then you could finally return a class from here. But that is quite a verbose solution, and creating an entire class just to return a value doesn't seem like a good solution. This is why in Dart 3, Google introduced something known as records. So to use records, we are going to remove this list, put parentheses, then we are going to mention the return data types. So we are going to return a double and a string, and we are going to return the same thing, but instead of a square bracket, we need parentheses again. And this is how simply we've returned two values from a single function. And this is exactly what records are. But here you might see an error. This error is there because records expose a getter to us. So if we just put dot, you see we get something known as $1 and $2. It represents the first element and the second element. The first element is double and the second element is a string. Now let's try to run it and see what we get. We get the same values. The advantage of this solution is that we know the type of the values here. So we know what's double, what's string, and we can make our computations based on that. Put a bracket here. Then we can give a name to a variable like point and greeting. Then we can use those values over here. So we have point and greeting like this. And then if we run it, we get the same values. This thing right here is called patterns, which is the second new feature that was released in Dart 3. So whatever record we are returning from here gets assigned to that specific variable. So since we are returning double first, we have named this point, and since we are returning string second, we have greeting here. So this works in a positional way. Now you might say that this solution is still not expressive because we don't know what value is being returned for what. So for this, we can use something known as named values. So just like a function, we are going to wrap this with curly braces. Then we pass a name to this variable and another name to this variable, and even here you have to pass in names. So just like a function, you can pass in point like this and greeting like this. And now you see we are getting errors over here because now we have access to the names of these values. So we have greeting and point. So now we have a clear understanding of what's returned to us. And if we run it, we get the same values. And these records don't just work for two values. You can return two or more values depending on your need. We can also create records on our own. So to create a record, we just create a normal variable, then set it equal to the normal parenthesis, which is the standard type for a record. Then we pass in the values. So we have 4.5 for a double, a string, and then a boolean and integer value. Now if we just try to print this record and run it, we get the correct values. And we can access them using $1, $2, $3, $4. One thing to note is that these records are immutable. And these $2, $1, $3, $4 that we are getting are getters. And the records don't have any setters because they are immutable. So that just means we cannot do records $2 equal to some value, because the error message says the setter isn't defined. So we only have a getter. Other than this, we can also define named arguments for these records. So we can just have greeting here and let's say is adult here. If we print it, we get that, and if we go to records, we get double and integer, which is 4.5 and 2, then the named arguments. And if we do records dot, we see $1 and $2, which stands for 4.5 and 2, greeting, and then is adult. Also, these records are type safe. That means if I change this to var and then do records equal to, let's say 2.0, then I pass in false, then I say greeting is hi and is adult is false, then here I get an error. The reason for this is I've passed the correct data type at first, which is double, but then I've passed in a boolean value. It shouldn't be a boolean value, it should actually be an integer. So if I pass in an integer, the error goes away, which means it's type safe, just like other variables in Dart. We can also make these records nullable. So if we just define it like this, double and integer, then we put a question mark just to show that it's nullable, and then give it a name. So let's pass in name equal to 4.52, then print the name, then I set name is equal to null, and then print name again. Let's see what we get. So you see, at first we get 4.5, 2, and then we get null. And the last thing that I want to show you in records is the equality of records. So if we have a record that looks like this, int, int, and int, then it has the variable name of point, and that is equal to 1, 2, 3 for x, y, z respectively. And then if we have another record that is similar to the first record, but instead of having x here, we have a, and here, since this one was a, this will be a as well instead of x, and everything else is similar. And then if we do point is equal to color, you see we get an error. This is because Dart considers both of these variables different from each other. For a record to be equal to another record, all the fields should be matching here. So if I just change this back to x, and then I'll have to change this to x as well, now we see point is equal to color. You can however change the values over here. So we have 5, 10 and let's say 12. You can do that, but these arguments should be the same for both of them to be comparable or assignable together. Records are real values. You can store them in variables, pass them to and from functions, and store them in lists. Now let's dive into patterns. We've already seen an example of patterns, but that's just not it. There's more to patterns. So suppose we have a list like this. So to get access to these elements, what we do is list at 0 or list at 1 or list at 2. But with records, that's not necessary. What we can do here is just put a, b, c inside a square bracket, just imitating this list, and set it equal to this list. So let's see what we get here. We can print it out like this, and we see 1, 2 and 3. But what if we have more elements than just 1, 2, 3? What if we have 4, 5, 6, 7, 8, 9 as well? Now if we try to run it, we are going to get an error, right? Because we have 9 elements and we are just assigning to 3 of them. To resolve this error, what we can do is just have ... at the end. Now if we have that, the error is resolved and ABC contain the value 1, 2, 3. And the rest are contained in these 3 dots. But what if I want 4, 5, 6, 7, 8, 9 as a separate independent array? We can get that as well by just doing D, putting a D after these 3 dots, and then having $D like this. Now if I run this, we have 1, 2, 3, which is ABC, and D, is a separate array because ... gave it access to the remaining elements. And obviously if the second element here doesn't matter to you, you can put an underscore here, so it will neglect that value, and this underscore isn't a variable. So if you just try to do underscore, it will come undefined. Now what if instead of a list, we have access to a JSON or a map? So if we have access to this, we are used to printing the values like this: JSON user ID, then running it, and then we get the user ID. With Dart 3, this can become much more simpler. With Dart 3, what you can do is just have final followed by user ID, then the name of the variable, let's call it user ID again, title, and then again pass in the name of the variable. So we have title and set it equal to JSON. Now if we try to print user ID and title, let's see what we get. And as expected, we get the user ID as 1 and the title as this thing right here. So we have destructured this successfully as well. We have a map, we've passed in the field name over here, then assigned a variable name to this, which is user ID. Then we can use this user ID anywhere we want. Then we have title, and then we've assigned a variable name to it as well and passed it over here. If you want to do it for body, you can again pass body here and whatever the name should be, let's call it B, and you can pass print B to it and run it, and you'll get the desired output. Doing stuff like this can often be error prone. So for this, it's recommended to put an if condition. And to follow the syntax, there's a special type of if condition that was introduced in Dart 3. So we have if JSON, which is the name of the map that we have used to get our values, case, which is now a keyword, then this part right here, the mapping that we have done. If this is the case, then it means we are successful with our mapping. And here you will see we are getting errors. The reason for that is we have not put final here, and we cannot put that in an if condition. So here what we can do is pass string user ID, string title, and string B. This will actually be an integer, but let's see what we get if we put string over here. And obviously we'll just print stuff out here. So let's copy it, paste it. Then we have an else condition, and in the else condition, let's just remove this. We are going to print out stuff again. Alright, so let's try to run it and see what we get. And you see we are getting incorrect JSON now. Why is that the case? Because we've passed in a string over here and the value retrieved is not string. It means that user ID is now having a type of its own, which is a good thing. So we can just pass in an integer, run it again, and we get the correct output. So just revisiting this if condition again, we just need to put a name of the map we are using to get the values from, in our case JSON, case, and if the case is this, that means user ID is there, which is integer, title, which is string title, and body, which is string body, then it's the correct thing, and then we print it, otherwise it's incorrect JSON. And if we mention the wrong type, we are going to get incorrect JSON. This if condition can also be rewritten in switch. So let's try to write it. If we have switch, JSON, and case is just like this, the same thing here. So we have user ID int user ID, title string title, body string B. Then we are just going to print these stuff out. Otherwise, we have incorrect JSON again. So let's remove this if condition now and run this. We get the same output again. And again, if you misspell anything or do anything wrong here, you'll get incorrect JSON. Another nice thing that you might have seen is I didn't need to put break over here, because that's optional in Dart 3. So if you pass anything here like print or any other statement here, you don't have to pass in break. But if you keep this empty and then run, you get incorrect JSON. Even though the JSON is correct, you'll get incorrect JSON because there was no break found, there was no statement here, so it went to default. But if you add break here, it will not print anything to the console. So for non-empty statements, you don't need to put break, but for empty, you need to put. Now let's try to get elements of a class. So this is the human class we have. The human has name and a age, and here and in the main function, we are creating an instance of human class and printing its name and age. And then when we try to run it, we get nice name and 2 as the name and age. That's how we did in .3 and before. But with pattern matching, what you can do is final human, then pass the name of the fields here, name, age with a colon before them, equal to human. And now you can print name and try to run it, and you'll get access to nice name. And similarly for age. So this is pattern matching in Dart for class related stuff. So here you need to mention the name of the class followed by a colon here, then the name of the field, again colon, then the name of the field again, which is equal to human. And you can also pass age here, name here, then try to run it, and we still get the correct output. But if you misspell this like this, suppose name is namey, and then you try to run it, you get a compile time error of course. That name isn't defined for the type human. Since your class name is human and there's no property of name here, you cannot use namey. So you need to pass name here. And if you're wondering why we need to put this colon before the name, that's because we want it to rename. For example, if this is the age property and we want to use ag like this, you can use this. Or if you want name property and want to call it something else, so let's call it something else, and then try to print it, you'll be able to use both of these values. It's kind of like mapping and it works. So the field is age and you're using the variable name ag, or you have the field name and then you're using something else. But if you want to go ahead with the default one, you can just go ahead by putting colon at the end or at the start, sorry. Now let's take a different example. What if we have a record like this, A and B, which have yes and no as their values, and then we try to print A and B, and then we try to swap them. So A comma B is equal to B comma A, and then we again print A comma B. Then what will we get? So initially we should be getting yes, no, that we get. Then we get no, yes, because we swapped it. So this is kind of similar to Python's way of swapping, and that is allowed with records and pattern matching as well. So now I have a different example with me. I have a list of items with the elements hi and man. Then I have a switch case where list of items has the case of hi and man, exactly what we have here. And if that's the case, then we are printing dude. If we are in .2 and try to run it, you see we don't get anything. Now if I switch to .3 and then try to run it, you see we are getting access to dude. That means it's able to recognize switch case conditions properly. And we can do this for records, for maps, or whatever we want. Another cool thing we can do here is check for two different elements in a single list. So I can just check here, putting an OR sign, saying if hi is this or hi is this and man is there in the list. If that's the case, then we are going to print dude. Then I'll try to run it and we get the same output. So that means if I put hi in the list of items and then try to run it, I get dude again. So we can put OR conditions here. How it's working is basically if the first element is either hi or hi and the second element is man, or you can also put or man like this or any other thing you want, it will work. Another cool thing you can do with switch cases in .3 is just put a when guard here. So when, and suppose we have int index is equal to 2, and when index is equal to 2, then only it should print dude. So when you try to run it, it spits out dude. So what's happening here is we are checking for the OR conditions and the entire list. Then we are checking when index is 2, then only print dude. Otherwise we can put a default condition, print bruh. And let's shift index to 1, then try to run it. And you see we get bruh. Since index is 1 and index is not equal to 2, so it went to the default condition because this case did not match. So this is extra addition guard that you can add to your switch cases. Another cool thing you can do with switch cases now is use them to assign variables or use them in Flutter itself in the UI code. So just to demonstrate it to you, I'm going to create two variables, page is equal to 0, last page is equal to 1, and then I'm going to have a text where I'm going to use switch case. So I'm going to have switch, then I'm going to pass in page. Then after the brace, we don't need to put the case keyword here. Instead, we can just match the conditions. So we have 0, which will be returning, let's say, click here. And then 1, which says click me. And then underscore, which means the default case. So you don't have to write default like this. You can just have underscore and then we can write none. And there we are. So we have used switch case inside of a variable just to assign it a value. Now if I try to print text and then run it, you see I get click here, which means I'm getting the condition executed when it was 0. Now if I try to use last page, I can run it. I get click me. Now I can also add a when condition if I want. So I'll have when, and then if I try to run it, I get none. Because the last page is 1 but page is not equal to last page, so I get the default case executed. Now if I just make page and last page both 1, then try to run it, I get click me. Now I can use this exact switch condition inside of the Flutter pad. So let's go over there, and here we are just going to have this. Let's create the variables, and you see we are getting none written over here. And if we make both of them 1, then run it, we get click me. So this was all about pattern matching, switch cases and if conditions. Now let's dive into the new class modifiers that we've got. So let's consider I have an abstract class called animal, and classes human and dog are implementing the animal class, and cat is extending animal. Now I'll create an instance of an animal class and set it to cat, and then I'm going to have a switch of animal and the case will be dog. And then when I try to run it, I get nothing printed out in the console. And that's expected because I've not handled the case of cat. So the problem I'm trying to solve is that whenever I put animal, I want all the subtypes of the animal class to be included here. And by subtypes, I mean direct subtypes. So I should be getting a compile time error or a compile time warning saying you've not handled all the cases of animal class. So to do that, Dart3 introduced a new modifier called sealed. So with sealed class now, we get an error. The error says that the type animal is not exhaustively matched by the switch cases since it doesn't match human. So we need to implement the cases of cat and human. So I'm just going to add case cat and case human, and then our error goes away. Since we've handled all the subtypes of animal class, we don't get an error. And when I try to run it, I get the print as cat. This is the difference between abstract and sealed class. There's obviously more, but sealed class is quite similar to an abstract class. For example, so when you try to instantiate the animal class, it says animal classes cannot be instantiated. So the sealed class is implicitly abstract. Another question that might be in your mind is, how does Dart do this? Dart does this because the sealed classes prevent other classes from implementing or extending it outside of the same library. For example, if I have library a.dart here, and if I have all of these defined in library b.dart, that's just not allowed. All of them need to be in library a.dart for this to work. Since they are in the same library, Dart is able to know of the subtypes of animal class. And by subtypes, I mean direct subtypes. That means if I try to have a class cat1 which implements cat, I won't be getting this in the switch case because this is an indirect subtype. Because cat1 implements cat and cat extends animal, it's an indirect subtype. But if I directly implement it from the animal class, I get an error over here. So that's about sealed classes. Other than sealed class, a bunch of other modifiers were introduced in Dart 3. The first one is final modifier. This final is very similar to the sealed class. It cannot be implemented or extended outside of the same library, but inside the same library, it can be extended or implemented. A basic difference between them is that animal class can not be constructed, but animal1 class can be constructed. So sealed class is very similar to the abstract class because it cannot be constructed like this, but final class can be. And another one is that if we have final anim here like this, and then if we try to have switch animal like this, it doesn't throw any error to us. So with the final class, we don't get the cool features the sealed class gives us. But final class does prevent classes outside of the library from being implemented or extended. The third one is base class. So base classes cannot be implemented, but it can be extended. So that means if you try to create class human extending animal2, it will work. But if you try to create class human implementing animal2, that won't work. And whatever class extends animal2 class needs to be base, final or sealed. That means if we have a class called human extending animal2, you see, we will get an error here saying it must be base, final or sealed. So this should be base, final or sealed. And the same goes for a final class. So if we are in the same library and then if we try to extend animal1, we get the same error over here. This also needs to be base, final or sealed. This is because the final class encompasses the effects of the base class. The cool thing with base classes is that whenever we extend this and call this human class, the constructor of the base class gets called. So whenever an instance of the human class will be created, obviously that won't be created with sealed, it can be created with final. So whenever human class is instantiated, the animal2 class's constructor will be called. Fourth one is kind of a reverse of base class, which is interface class. Base classes could only be extended, interface classes can only be implemented. So even if you're outside of the library, you can implement the interface class but cannot extend it. And this interface can also be constructed. For example, if we have animal3 like this, we can do that. So this is not a true interface from other programming languages. So to make this a true proper interface, what you'll have to do is combine it with abstract. So you have abstract interface class, which you can use, and this is a true proper interface. So if you have animal4 like this now, it cannot be constructed. It has the properties of both abstract and interface. So now this is a proper interface with us in Dart. And the last modifier that we have is a Mixin class. And as the name suggests, it's a Mixin plus a class. So it will be used as a class as well as a Mixin. So you can use the with keyword. Now you might say, why do we need a Mixin class here if we have a normal class animal5 which can be used with the with keyword? For example, if you have class human, we can use this with animal5 class, right? But that's not the case in Dart 3. In Dart 2, you could do this. But in Dart 3, with keyword for a normal class is removed. You'll have to use Mixin class for it to be used with the with keyword. So that's one breaking change in Dart 3. Nothing else is quite breaking. These are all additive features. So a normal class cannot be mixed in now, but a Mixin class can be. So this was all about Dart 3. I'll be bringing in a dedicated course on Dart, including Dart 3, within the next 2 to 3 weeks. So if you're confused about any of the stuff I talked about in this video, make sure to leave it in the comment section and I'll put more emphasis on it in the Dart course. Thanks for watching and I'll see you in the next video.